Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. We are presenting our mini project entitled OKU Friendly Pedestrian Traffic Light System using ATMEGA64. My name is Muhammad Zubai, and together with my partner Muinuddin bin Muhammad Maliku, we developed a smart pedestrian traffic light system that is more accessible for people with disabilities, especially the visually impaired and hearing impaired. Nowadays, standard pedestrian traffic lights only use red and green signal. This creates difficulties for OKU users, especially blind people who cannot see the light and deaf people who may miss other warning signals. Because of this, crossing the road can become dangerous and may increase accident risk. Therefore, we designed an intelligent pedestrian crossing system using the ATMEGA64 microcontroller. Our system includes a push button, an LCD countdown displays, and traffic light LEDs. These features make road crossing safer and more accessible for everyone. There are three main objectives of our project. First, to design and simulate an accessible pedestrian signal system using the ATMEGA64 in Proteus. Second, to develop the embedded C program using Microchip Studio. Third, to provide a real-time visual and audio information for pedestrians. The scope of our project focuses on a push-button pedestrian crossing using simulated hardware components in Proteus. Our system has one input, which is the pedestrian push button. The outputs include vehicle traffic LEDs, pedestrian LEDs, and LCD countdown display. This operation is simple. When the pedestrian presses the button, the vehicle stops, the pedestrian light turns green, the LCD displays the remaining crossing time, and after the countdown finishes, the system returns to normal traffic operation. For the flowchart, this flowchart shows the overall operation of the system. The program starts by waiting for the push button. If no button is pressed, vehicles continue to receive the green light. Once the button is pressed, the traffic light changes from green to yellow and then red. At the same time the pedestrian green light turns on, the LCD starts the countdowns. After the countdown ends, the pedestrian light turns red and vehicle traffic resumes. For this first slide of the coding, define f underscore CPU 8 million UL. This defines the microcontroller clock speed as 8 megahertz. Include avr/io.h. This library allows us to access all ATMEGA input and output ports. Include util/delay.h. This library is used to create timing delays. We define names for each LED, LCD pin, push button, and buzzer so that the code is easier to understand. For this slide, DDRA equal 0.ff. All pins on port A are configured as outputs because they control the traffic light LEDs. DDRD equals 0 times 00. Port D is configured as an input because the push button is connected there. Before using any hardware, the microcontroller must know which pins are inputs and which are outputs. And then if we set a bit to 1, that pin becomes an output. If we set it to 0, it becomes an input. For this slide, LCD function, this section contains function for sending commands and characters to the LCD. Instead of writing complicated LCD instruction every time, we create reusable function. Initialize LCD, display text, move cursor, and for the main function, the main function is the starting point of the program. When the ATMEGA64 is powered on, it immediately begins executing the instruction inside this function. The while one loop runs forever. Since the traffic light system must operate continuously, the microcontroller keeps repeating the same process without stopping. And for the push button detection, the controller constantly checks whether the pedestrian button has been pressed. If no, vehicles continue moving. If yes, the traffic light sequence begins. I think that's all from me. I will pass to my partner to continue present about this mini project. Thank you.
Okay, Assalamualaikum. My name is Muinuddin bin Muhammad Maliku, and my ID number is TB 24034. So I continue for the circuit parts. So this slide shows the complete circuits of our OKU pedestrian traffic light. So the main controller is used the ATMEGA64 microcontroller is connected to the traffic light LEDs and pedestrian LEDs, push button, LCD display, and the 7-segment display. The microcontroller controls all input and output device based on the programming written in the microchip studio. So next, this slide shows another views of circuits during the simulation. The LCD is used to display message and the countdown timer. The pedestrian indicate the vehicle and pedestrian signal, while the push button acts as the input to request a pedestrian crossing. The 7-segment display also show the countdown for the user. So next, condition when push button not pressed. So here, when the red, the lamp LED of the pedestrian crossing is red, and the green for the traffic light. So that's mean the pedestrian is not allowed to crossing. Next, after 10 seconds, when the pedestrian presses the push button, the system start the countdown. The countdown is displayed on both the LCD and the 7-segment display. During this period, the traffic light prepares to stop the vehicles before allowing pedestrian to cross safety. So next, when the condition for the traffic light occurs, when the condition is at 5. So when the countdown, sorry, when the countdown reach 5 seconds, the vehicle traffic light changes from green to red to yellow to warn the drivers that the light will soon turn red. After the countdown reaches 0, the vehicle light turn the red and the pedestrian light turn to green and pedestrian can cross safely. So this is a link for video demonstration. Can get more details and information. So for the discussion, a project was successfully developed using the ATMEGA64 microcontroller, LEDs and LCD and a push button. The system allows pedestrians to request a safe crossing by pressing the button. Once activated, the vehicle traffic light changes accordingly and the LCD displays a countdown to inform pedestrians of the remaining crossing time. Overall, the system provides a simple and effective pedestrian crossing solution. Next, for the conclusion, our vehicle traffic light system achieved its main objective. Thus, the system provides a safer and more organized pedestrian crossing process using traffic lights, an LCD countdown, and a push button throughout this project. We also improve our knowledge of embedded system, microcontroller programming, circuit design, and hardware interfacing. So that's all from us. Thank you.